lesson on states and properties of matter. There are 4 states of matter: solid, liquid, gas, and plasma. And I'm going to concentrate on how the motion of the particles are. Solids, all substances will vibrate. All the particles will vibrate or move in some way. The only time that no motion exists is absolute zero, which is impossible because electrons would fall into the nucleus. So solids, they are locked into place. They have one location in space where each atom or particle exists, and their motion, though, is vibrational mostly. They vibrate, rotate, some other twisting and bending if possible. The atoms or the particles touch. They are organized. And touch the same neighbors all the time. Since they are locked into place, they have the same neighbors. The little kid definition, they have a definite volume and shape. So that's solid. Liquids, they are not locked into place. They can change their location in space. So what their motion is, they vibrate, rotate, spin, whatever you need to do on a moving point. They zigzag, move around, things like that. They are less organized. They don't follow a set pattern. They are touching neighbors, but they're different over time. Sometimes they're touching some atoms, particular atoms, and then they move along, then they're not touching any of those. But they always touch, but they don't touch the same neighbors. They have a definite volume, but will fill the bottom of the container. So their shape changes depending on what container they are in, or not in, depending on what that is. Gas, they have no organizational location at all. They have free linear motion. They still spin and vibrate, but most of their energy is going into motion. And their motion, energy due to motion, is kinetic energy, which I forgot to mention before. The atoms don't touch except when they're bashing into each other, so the particles don't touch only when bouncing, only when bouncing off each other. There's lots of empty space. There's lots of empty space between the particles. In fact, in a gas, most of the volume of a gas is empty space or nothing. come back here and represent these. Since solids are locked in place, if you were to draw that, they are very organized in rows and columns and nice and neat. Liquids, they're touching, but they're not as neat as you would think. And there are voids. There are empty spaces in there. Gases, represented by free linear motion, particles not touching, moving, zipping around. Plasma is the fourth type of matter. It has more energy added into it so that electrons are added or removed. So plasma, one characteristic of plasma is a glowing gas. Examples of sun, lightning, neon fluorescent bulbs, plasma screen TVs. These are all examples of plasma. And that's all we're going to mention about plasma because we don't work with it that often. Changes in state. As you add energy, a change of state, as you add energy, add heat, the atoms move faster, and when they move faster, they break some of the bonds, or all, depending upon what the gas phase, or if you're going to do gas or not, of the bonds or connections in between the atoms, therefore changing state. Diagram of that. This is more energy. Go over here. More energy. Gas. Liquid. Solid. Less energy. And if you add energy, you're going higher. If you're removing energy, you go down. If you're going from a solid to a liquid, that is called melting. If you're going from a liquid to a solid, that's called freezing. If you're going from a liquid to a gas, that's called boiling. If you go from a gas to a liquid, that's called condensing. If you're going straight from a solid straight to a gas, that's called sublimation. If you're going straight from a gas back down to a solid, that's called deposition. And somebody pointed out that that makes a nice little pumpkin. Jack-o'-lantern. Okay, so that's the states of matter. Now the properties. There are four sets of properties we're going to talk about. There's the physical. The physical property do not change substance when observed. things like crumpling, bending, ripping, water freezing at 32 degrees, water boiling at 100 degrees Celsius. These are all physical properties. Color, color of the substance, whether it's a solid, liquid, or a gas. These are all examples of a physical property. Chemical property is closely is the opposite of that. You do, or you could, get a new substance if observed. If observed. The easiest one to get a feel for is burning. Chemical property of burning means it is flammable or inflammable, which means the same thing. Flammability. So a brick would be have not flammable, so it's a do or do not type situation. Whether something burns or not is that. And what flammability, what burning is when it combines with O2. Other chemical properties, examples, could be reaction with an acid, reacting with a base. Pick a chemical reacts with water, or not. The non-reacting things. People will say that the inert gases have no chemical properties because they don't react with anything. Well, that's not true. Chemical property is they do not react with something. The other two sets of properties are intensive. An intensive property does not matter how much, the amount does not matter. For example, a piece of mirror will reflect light. A big mirror will reflect light. A small mirror will reflect light. They both will reflect light. Whether all chemical properties are intensive, you'll get more energy or something like if you burn a big log versus a small log, but the fact is they both will burn. So all chemical properties are that way. Extensive properties really are more rare. There are many more intensive properties. The extensive properties, size matters. The amount of the substance you have is a factor. It does matter. Traditional one of this would be mass, dimensions, volume. Those are the ones that you usually hit on that. That concludes this lesson on properties and states of matter.